So at the end of the
Okay, so
class, I
this
would be sending you this recording so that you can refer at later point of time.
okay, so this is officially our first session, right?
Yes, yes, Rini. Yeah.
Okay.
So we would be starting with the definition of the data warehousing.
Uh-huh.
Okay, so let's start the class. So Bill Inmon is considered as the father of the data warehouse, Srini. It's like a father of internet, father of C, father of C plus would there, right? So Bill Inmon is the
Right.
person who in 1970s, okay, he had come through a concept. He had gone through a concept called, okay, in order to overcome the problems which we are facing with these OLTP systems, he has proposed a kind of system, and he felt that if the system satisfies these requirements, then it would be very easy to do the reporting. At the same time, we can analyze the data in different ways. So what is his point of view was, according to him, a data warehouse is a subject-oriented, integrated, non-volatile, time-variant collection of data in support of management decisions. So this is one. So basing on this definition, most of the data warehouses, all of the data warehouses are built in the current situation. So even though the terminology differs, even though the naming convention differs, even the backend differs, but the whole basic point of building a data warehouse would be basing on these principles. So a data warehouse is subject oriented. So subject oriented in the sense, in an organization there will be different departments: finance department, HR department, sales department, like that n number of departments would be there, who is which play an important role in part of the organization. So every department is important for an organization. It's not that one department it can ignore and one department. So whatever the department wishes to do reporting should be included in this one. So a data warehouse is subject oriented, which means the data is stored separately, subject wise, department wise. Next, integrated in the sense, normally organizations would be holding their data in n number of ways. So if they have implemented a SAP ECC or any other ERP application, then most of the time all of the departments would be storing the data in that particular single application. If that is not the case, some people would be using databases, some people would be using Excel sheets, some people should be using Access database, and any other maybe third-party tools. So a data warehouse should have capability to integrate these many sources of data. To integrate sense, it is able to read from these different sources, combine and put into it. So that is the definition of the integrated. And non-volatile in a sense, so it's like a non-volatile means not changeable at all, which means every time whenever we refer to the data warehouse, we would be seeing the constant data, which means if you take about SAP BW as our example, what we would be doing is we would be loading all of our data from different source systems once the business hours are closed and put into the BW system, and we are ensuring that none of the data is getting updated in the runtime on the daytime especially. Okay, so whenever we are referring to a data in the data warehouse, we are referring till yesterday's data, not today's latest data, which means we are making sure that we are having the constant data, consistent data, not changing in the runtime. So it can be, but according to the requirements, we can change that. But according to him, and at the same time, he makes sure that, okay, for example, today you have executed 2013 whole revenue data, for example. And tomorrow also if execute it should get the same data, which means the data in the data warehouse should not be deleted at all. It should be constant all the time and consistent all the time. And time variant in the sense, the data warehouse in the data warehouse, data should be stored in such a manner that it stores according to timing. I mean, according to some basing on some time period. It can be a calendar month, calendar year, calendar day, fiscal year, fiscal period, whatever it may be. But if you store the same in the same as in considering the time things, then it would be very easy to analyze the data. So that is the reason the Bill Inmon considered this definition of a data warehouse is a subject-oriented, integrated, non-volatile, time-variant collection of data in support of management decision. So basing on these principles, all the data warehouses are built in the current market. So the examples of the data warehouse systems are SAP BI, BW, or anyway BIW, BW, BI, all are same. Informatica, IBM Data Stage, OBIW, Oracle's, MSBI, Microsoft Business Intelligence, and these are considered as the data warehousing tools. And the reporting tools would be the Devo, ClickView, Cognos, Tipco Spotfire, Tableau. These are available in the current market. So whenever we are referring to data warehousing in the sense an ETL process. So it will follow an ETL process in order to load the data from the different source systems and the target system. So from now onwards, whenever I am referring to source systems, the source system can be anything, SAP system, non-SAP systems. So if I talk about SAP systems, SAP BI can itself be a source to the SAP BW system. SAP ECC system or SAP ERP system, SAP CRM, SAP SRM, SAP BODS. And when I talk about non-SAP systems, it can be any databases, Oracle, Teradata, SQL Server, Sybase, any leading market database providers. And if I talk about files, then it can be .txt file or .tsv file, CSV file, and any other third-party tool I can connect. So whenever I'm referring to the source systems, then these can be my different source systems. And in our case, whenever I'm referring to target system, I'm referring it as a SAP BW system. And in the current market, everything is considered as a data warehousing tool. But in reality, data warehousing tools are again broadly divided into two areas. One thing is called as the ETL and another one is called as the reporting. But in normal common terminology which we would be using would be data warehousing tool. So if we talk specific data warehousing tool, okay, which follows the ETL process, then this SAP BW, Informatica, OBIW, Kettle, Data Stage would be falling into ETL process. And pure reporting process in the sense ClickView, Business Objects, Tableau, Spotfire, like this. But the advantage of working with SAP BW is it's a ETL plus reporting tool. So ETL stands for extraction, transformation, and loading. Extraction means extracting the data from the different sources. So whenever I have different sources, SAP systems, non-SAP systems. So extracting the data from the different sources, transformations, which means transforming the data according to the reporting requirements. So whenever I'm referring to a word called transformation, Sri, could you please go on? I'm echoing my voice. So whenever I'm referring to a word called transformation, which means it's not that all of the people would be storing the data in the same pattern. For example, in SAP, we would be using the naming convention. I mean, for example, there's a country field. So in SAP, maybe according to their requirement, they would be using a shortcut names. Australia means AU, India means IN, United Kingdom means UK, Germany means DE, India means IN. Okay, maybe these may be using these shortcut names, and one of the databases would be using the full names: United States of America, United Kingdom, Australia, India, NZ, New Zealand. So, but when there comes a situation where you need to combine the data from the different sources and it's show in a single report. But here the same country field in SAP is the values is stored in different format, AU, NZ, IN, UK, like this, and the same country field in a database table would be stored in some other format. They are using the full names. But how come I do a report with different names over here, even though they are referring to the same country field, but here IN and there India, so which are getting a problem, right? That is the reason we would be using these transformation techniques in order to transform the data so that the different source systems would look like the same. The data in the different source systems, if you feel that we are going to combine the data from these different source systems and do a reporting, we make sure that whatever the objects we are going to do report on. So normally country would be also one of the key field where we would be doing reporting. Country-wise revenues, country-wise sales. Okay, so so using these transformations, we make sure that whatever the data we are picking from the different source systems, using these transformations, we will be transforming the data. So we would be writing the different codes in order to transform. So I would be writing if for example the SAP system is getting the shortcut names and the Oracle database or the flat file is storing the full names. So whenever I am reading data from the SAP system to the BW system, so I would be writing the different if conditions. If country name is equal to AU, the result is equal to Australia. If country else, not else, multiple if conditions, or I can go with a case statement, case country, when Australia, result is equal to when AU, result is equal to Australia, when IN, result is equal to India, when NZ, result is equal to New Zealand. So in that way, I'll make sure that the data which is coming from the SAP and data which is coming from the flat file would be storing the data in the same format, and that is applicable to different date fields also. For example, normally in US the pattern is first the month will start, month, date and year. So in India especially, date, month, year. So some people would be following, for example, today's date is 9th 10th February, right? So in India, so 10.02.2014. Some people will be following this pattern. So 10/2-2/2014 or 02-10-2014. So different people would be storing the data. So different people would be using different conventions in order to store the data. But when I want to load the same data into BW system and do a reporting, I need to make sure that all of the people would be following the same naming convention. Okay, so that is the reason I would be using these transformation techniques. For example, the standard naming convention for a year, for a date in a SAP system is DDMMYYY, which means this is the format you should give when you load into the BW system. So you should also ensure that whatever the data you are reading from the flat file would also have the same data in the same naming convention, in the same pattern. Otherwise, what would be you doing with the help of the transformations that are available in the BW system or any other system, okay, any other data warehousing system, you would be changing things. So in this way, these transformations would be very, very helpful to you. So this is about the transformations. Next, loading. So once you feel that everything is matching according to the requirements and you are making sure that the source data is combining good, okay, with the same, they are following the same naming convention throughout the things, then we would be loading the data into the data warehousing system. So there ends the story of the ETL process. So once the ETL process is done, which means extraction, transformation and loading, then comes the picture of the reporting. So basing on the loading of the data, whatever the data you load on top of the tables that are available in SAP or any other data warehousing tool, you would be creating the report first of all, and later on executing the report and making sure that the report holds the information which the manager is requesting. So once this process is done, so this process called as the ETL process plus reporting process. If you go with any other tool, for example Informatica, then it is good at reading the data from the different databases. But when I connect to SAP BW system, SAP systems, it is not not having that good capability. So Informatica is good at reading the data from the databases especially. And when it comes to reporting, it needs to implement any other reporting tool on top of that one. It only does the ETL process only, no reporting process. But when it comes to SAP BW system, it does the ETL process in the SAP system as well as the reporting by using the tool called Business Explorer. So we have two tools in Business Explorer: Business Explorer Query Designer and Business Explorer Analyzer. So in the Query Designer, so it is clearly telling to you the definition itself, query. So in SAP BW terminology, A report is considered as a query, which means query in the sense a question. So yep. So in the query designer, you would be designing the structure of the reports. So what are the fields should be mapped, and what are the key figures, what are the different things should appear in the report. So once you are done with the creating of the structure of the report and saving of the report, then you would be jumping to the Business Explorer Analyzer tool. This is used to, the definitions are again telling analyzer. This tool is used to analyze the data. So according to your requirement. So if you want to analyze that according to calendar revise, okay, just drag and drop that field, and everything is done. If you want to see the data in terms of material wise, country wise, sales region wise, so whatever point of view, so how many fields you are having in your table, that many point of views you can use the data. For example, if you consider the employee table, then employee ID, employee name, employee department, employee salary. Okay, so these were the 4 fields. Out of these 4 fields, one is a numeric field, which is nothing but a salary. Okay, so you can analyze this data in so many ways, from employee point of view, from different departments point of view, from name in the sense we are not going to make that kind of decisions over there. So in this way, with single presence of the data in SAP BW, we can read the data from these many sources and put into our BW system. And every BW system would be following this build involved definition as their backend architecture. So basing on this definition, they would be defining the things. So let's come to the definition of a data warehouse. Let's start with the second definition, which would be very simple for us to think. A data warehouse is a copy of transaction data specifically structured for querying and reporting. So what is the data warehouse data? It doesn't create any new data, or we are not going to enter any data into data warehouse. It is nothing but whatever the transaction data that is available over there in an organization. So we would be reading that particular data and storing in a separate system called as a data warehousing system. In our case, it is a SAP BW system. So what is this? A data is a copy of the transaction data which is copied daily. So when the business hours are closed for an organization, for example, Walmart is there. Once the business hours are closed at for example 9 p.m. in the evening, so at 11 a.m. or 11 p.m. or especially most probably at 12 a.m. we would be running few jobs in the back end. So what that jobs will do is those jobs will read the data from the respective tables which got updated on the particular day, pull that particular data and put into the BW system. So when the manager comes tomorrow morning and when he executes the report, then the system ensures that we the IT people ensure that the data is available for the yesterday's data till yesterday, whatever the business has been undergone, that particular data would be available for reporting. When the manager executes the report the next day. So nothing but a data warehouse is a copy of the transaction data, but which is specifically structured. So the data warehouse system is structured accordingly so that it supports a good querying and reporting, or fast querying and reporting. Coming to the first definition, a data warehouse is a central repository for all or significant parts of the data that an enterprise's various business systems collect, which means an organization has different departments, and whichever department want to do reporting, then they can, instead of doing reporting on their own OLTP systems, they can have a OLAP system in their organization, and whatever the data they want to pull. So for example, there are 10 departments. 3 to 4 departments, they don't want to do any reporting. They are not bothered about. They are just bothered about storing the data. And the rest 7 departments wants to do reporting. So what we are doing is we would be reading the data for those particular 7 departments and putting into our data warehousing system and start reporting. So that is the reason. So which means even though in an organization we have multiple systems, one department would be using the databases, some department Excel sheets, like this, multiple systems would be there, but we have a single data warehousing system wherein we would be pulling all of the data and putting into the single system and doing reporting according to the managers or according to the department's requirements. So in this way, a data warehouse is a central repository, which means only one system for all of the data that an enterprise's various business systems collect. In this way, we can define the data warehouse. And coming to the third definition, a collection of data designed to support management decision. Okay, sometimes there comes a situation when we need to combine the data from one or more departments and do reporting. So in that case, then this data warehousing system would be helping us in order to make such kind of decisions. So data warehouses contains a wide variety of data that present a coherent picture of business conditions at a single point in time, which means we are making sure the data warehousing system would collect all of the information at the same time. So we ensure that at 12 a.m. in the morning or 1 a.m. in the morning, whatever the data we would be planning to do reporting, we are able to read the data from the respective source systems and putting into our respective data warehousing system. So we are making sure that so tomorrow morning when the manager executes the report, even though the report is based on multiple departments of the organization, it is ensuring that it is showing you a correct data with respect to that particular point of time. Point of time in the sense, yesterday's data, we are making sure that 100% that is available in the BW system by running the different jobs. So this is how it goes in a data warehousing environment. So this is again a overview of what the expansion of the INMON's definition. So the same subject-oriented, integrated, time-variant, non-volatile collection of data in support of management decision. So this is how a data warehouse looks in a real-time environment. So see, these are the different sources. So whenever we are referring to a data warehousing architecture or a definition, first of all, we should come from the downwards, because the down contains the source systems from which we are going to read the data. The middle layer contains the data warehousing system, and the upper layer contains the reporting layer. It's called as the reporting layer. So this operative data and external data is nothing but our different source systems where we are going to read the data from. And the center layer is called as the data warehousing. So data warehousing system is built basing on this definition: subject, integrated, non-volatile, and time reference. And once we store the data into the data warehouse, so we are reading the data from this data warehouse and creating a different types of reports. Say, creating reports, creating graphics, calculating tables, and doing some analysis on the data that is available in the data warehouse. So these data warehousing systems would be very helpful in order to achieve all these reporting feats. Okay, so this is now how a data warehousing system is built. So the downwards different source systems, the middle layer is considered as the data warehouse, and the upper layer is considered as the reporting layer. Or in terms, different source systems, the data warehousing layer is called as the ETL layer, and the third layer is called as a reporting layer. So source systems, ETL layer, reporting layer. So we need to first of all discuss about the OLTP and OLAP system. So in the last two classes, I think we have just covered what is the OLTP and OLAP. So in an organization, the day-to-day transaction data where they are storing is considered as the OLTP system, online transaction process. So day-to-day transactions, whatever the business is happening, okay, whatever the sales are happening, to which customer are they selling the product, how much, all the particular kind of information. So whenever a thing is created, then the sales order is created, purchase orders, the financial orders, general ledger accounts. Okay, so all these kind of day-to-day activities related to different departments of the organization would be stored in OLTP systems. So our SAP ERP, our SAP ECC is also one other type of the OLTP system. the different databases, Oracle database, SQL Server, my Sybase, Teradata, all these fall under the concept of OLTP systems, which means these systems are capable of holding the OLTP information very quick manner, and these systems are optimized for writing the data, which means that is the reason whenever we go to a store and do some transaction, the things are happening very fast because these systems, the backend systems, are optimized for writing the data into the respective tables very fast. Okay, so these kind of systems are called as the OLTP systems. So whichever organization you go, whichever area you go, a store, airlines, banking, all these would be using these OLTP systems as their backend in order to store the data. And the OLTP systems consists of tables, that's it. Tables, and each and every table consists of the columns and the rows. And the rows contains data and columns contain the header values. So, and each and every table is joined with one another by using the primary key, foreign key concepts. So, in this way, multiple relations would be existing between the number of tables, and the data is getting updated into these particular tables at very frequently, because when the store is open, then lots of customers would be visiting and purchasing some or other thing and making the bills, right? So that is the reason these tables are getting updated very frequently. That is the reason these tables or these OLTP systems are optimized for storing the data or writing the data into the tables, and these would be using the different tables in order to store the data. And when it comes to reporting, these systems are very good at storing the data. But when we want to analyze the data, these systems are missing some kind of features. Particular features are, for example, if you want to do some analysis, then that is not possible. If you want to have some GUI kind of environment, that is not possible. And you are not getting the consistent data all the time, because the backend, the tables are getting updated regularly, very frequently. For example, you want to see today's sales. Then if you execute the report today at 1 p.m., then the numbers are different. Numbers are something. Then if you execute the same report on the 2 o'clock in the system, 2 o'clock, then the numbers are totally different, because in the back end, the data is getting updated regularly, very frequently. But in the case of the data warehousing, the things are different. We are storing the data, we are reading the data only once a time, once the business hours are closed, and making sure that the data is consistent in the data warehousing system. But that is not applicable to the OLTP systems. And at the same time, people would be getting in order to do reporting, and if you want to have the consistent kind of reporting, you need to log the users, not to enter the data into the business, not to enter the data into the respective tables, which means you are stopping the business. So that's a stupid thing. For just simple reporting purposes, you can't stop the business users to enter the respective table. So these are the drawbacks which are getting problems when we want to do reporting, or when we want to analyze the data with respect to the OLT systems. That is the reason the OLAP systems comes into picture. So the difference between these two systems is the way they are going to store the data. In respect to OLTP, the data is getting stored in the tables, and the tables are interlinked with one another by using the primary key and foreign key concepts. But when it comes to OLAP systems, the data is stored in some different kind of architecture called as star schema or extended star schema, snowflake schema, hybrid schema. So these were the different flavors which different data warehousing systems would be using in order to store the data. So these different architecture allows us to do whatever that we are missing in the OLTP systems, which means good analysis, reporting, what if analysis, and making sure the data is consistent, and all the other stuff which we are missing with OLTP systems. So that's the reason we need to have a thorough understanding of what is the difference between OLTP and OLAP system. So whenever we are referring to OLAP systems, which means we are referring to a data warehousing system. And whenever we are referring to OLTP system, means we are referring to any of the transaction processing system. So examples are SAP ERP, Oracle ERP, different databases, flat files, access database, and any other third-party tools where the organization is storing the day-to-day transaction data. And when it comes to OLAP, there are different data warehousing tools which we discussed earlier. So first of all, let's analyze what is the difference between the OLTP systems and the OLAP systems. So what is the primary operation of the OLTP? Its requirement is to update the data regularly in the backend tables. But when it comes to OLAP, it is designed to analyze the data. Okay, and level of analysis what we are doing in the OLTP systems is very low because this is not going to support much features. But in OLAP, we have lots of features in order to analyze the data. That's the reason the level of analysis is high over here. And amount of data per transaction very small and OLAP very large, because whenever what is happening is amount of data per transaction is very small over here, because lots of customers would be visiting the particular store and they would be having their purchases. They would be having their purchases. So what is happening is the respect data is stored in the backend. But when it comes to reading, so once the business hours are closed, what we are doing with the OLAP system, we are reading all of the data that was updated today, right? That is the reason the amount of data with respect to that particular transaction would be very high with respect to the OLAP system, which means since it is reading all of the data. For example, you have purchased some Arrow shirt of 42 size. Maybe other people would have also purchased the same shirt, okay, same Arrow shirt and 42 size. So with respect to OLTP, it's a single transaction, but with respect to OLAP system, what it will do, Arrow 42 size. So it will read all of the transactions that have happened with respect to this material and store it into the OLAP system. That is the reason the amount of data per transaction or per item would be more compared to this one. And what is the type of data over here? It is a detailed data, which means it would be giving each and every information about the transaction, which means the date of purchase, the store ID, store details, and the number of items he has purchased and all the other things. But with respect to OLAP, it is a summary kind of information, which means we are going to read only the relevant information what we want for reporting. We are not going to read all of the, for example, a table contains of 100 columns or 100 fields. It's not that we are going to read all of the 100 columns and put into BW, into the data warehousing or OLAP system. No, we would be totally focusing on whatever relevant for reporting and reading into the BW system. And at the same time, the data is available in the detailed format in the OLTP system and in the summary format in the OLAP system. And relevancy of data. OLTP always holds the current information only. Most of the times it would be current year only. So the previous years or the last years, we would be doing archiving. Archiving in the sense, removing the data from the production system or the live system where we are going to store the data and putting into some different systems. When it comes to OLAP system, the OLAP system contains all of the organization's information from day one till today, which means it contains a historical data plus current data, that is the reason we can do some good analysis with respect to data in the OLAP system. If you want to compare, yes, in the February 2014, Jan 2014, what were my sales, and compared to last 5 years, which means Jan 2009, Jan 2010, Jan 2011, Jan 2012, Jan 2000. So I can compare the increase or decrease in the sales via graphs, because I do hold the OLAP systems hold all of this information. But with respect to OLTP, I can't do this kind of reporting. Okay, that's the reason the OLTP stores the current information all the time, which is stopping you from doing the analysis. And the OLAP system holds the current and historical, so which is allowing you in order to dig into data and do some analysis. And data updates where often, very frequently data is getting updated. But in the case of OLAP systems, less frequent, because we are making sure that the system picks the data from the OLTP to the OLAP system once the business hours are closed. That's it. So, and at the same time, we also ensure that we only load the new data which was created or changed from the last load. Which means, say for example, today some 100 transactions happen. Okay, so we ensure that we read only that 100 transactions only. It's not that reading all of the data from the OLTP systems and putting into the OLAP systems on a daily basis. No. So we have two types of loads in data warehousing environment. One is called as the full load, and another one is called as the delta load. So whenever we are referring to the full load, we are doing it for a one-time activity. So when we first time create the system, then we are going to do a full load, which means it will read all of the data from the respective tables and put into our data warehousing solution. From the next time onwards, whenever we read the data, we ensure that the system only reads the newly created records or the changed records from yesterday. Okay, so that it would be having a very minimal data when we load the data into the OLAP system. Okay, so these are the different data updates. So very often and here very frequent. And the database concept is complex over here because lots of tables are involved and there's a lot of relationship to be involved. But here the OLAP system is simple because we are going to load only relevant data and we are going to create structures on our own, because whatever we want for reporting, only the particular structures we are creating. We are not going to mess up the things by loading all of the respective tables from the OLTP and OLAP into the OLAP. No. Whatever meant for reporting, only that particular tables, and we are going to update only that particular data only, not all of the information. So that is the reason here the concept is simple. And number of transactions, many, because lots of salespersons are saving the data in the respective tables, and here only few, because only few managers would be executing the reports. Nobody is entering the data into the ring. Managers who are responsible for making some decisions would be analyzing the data, picking up the data and analyzing. That's it. That's the reason only few people would be. And here time frame, so the point in time and the time period. And here database data, it is a normalized database and it is a denormalized database. Number of tables per transaction, several and few, and types of processing, it is well defined, and here it is ad hoc. Ad hoc in the sense on-time reporting. So initially the manager is viewing the data from customer point of view. Suddenly he wants to view the data from country point of view. So then that type of ad hoc decision is supported by the OLAP system. So these are the major differences which we would be focusing with respect to the OLTP and OLAP. So out of these things, the most important are relevancy of data, which means the OLTP holds current, OLAP current plus historical. OLTP optimized for writing the data and OLAP optimized for reading the data. Okay, and the database data, it is normalized and here it is denormalized, and the number of users are very high in OLTP and very low in OLAP. So this is how the OLTP and OLAP systems are designed, Srini. So till this point, any doubts, Srini? You want to ask me anything?
No, I think I'm okay. Just about the normalization of data. What exactly is when you say
normalization of the data? I'll cover this in tomorrow's class, Srini, because this is a concept which we need to have some kind of information. So what is normalization? Basically, in a shortcut, for example, the normalization allows you to store the data in different tables, which means, for example, you are storing all of your information in a particular table, Srini. Your personal information, your official information, and all the other stuff related to you, for example. Then what the database suggests you is, instead of storing all of the data in a single table, why don't you go and split the data in with respect to different tables? For example, your personal information in one table, the official information in another table, and the business information in another table, and your other information some other table. So it is proposing you to store your personal all your information in 4 different tables, so that it is very easy to access the data. Which means, if you want to have the personal information only, what you can do, you can directly jump to the personal table and read the data. If you want to access some business information, it will directly jump to the business table and access data. If that is not the case, what is happening is, the system is trying to read all of the data from the respective one table, even though it is relevant or not. So it is wasting a lot of resources in the back end in order to read the data. So in order to overcome this problem, the data warehouses proposes to store the data in a normalized fashion, which means, if we talk about some real time, then the transactions data would be available in respective table, and the customer's information would be available in the respective table. Material or the product's information would be available in the respective table. So in this way, it allows you to store the different information in different table, and you can club them at runtime, and at the same time you can, whatever the data you want to relevant, you can pick up and read the data. But when it comes to denormalize, the things are whatever I have discussed. So instead of storing the data in different tables, it allows you to store the data in a single table. But since we have the feature, since the overlap systems would be very fast in analyzing data, because that is their built-in feature. So even though we store the data in a denormalized fashion also, then it would be very easy for them to read the data. And this normalized fashion would be allowing you to store the data in a very quick manner. And even though overlap systems have already predefined feature, right? That is the reason, even though you don't store the data in a denormalized fashion, it would allowing you to do a good and faster reporting. So this is the difference between the normalization and the denormalization. If you want some extra information, I can prepare a slide for tomorrow's class and give you a deep insight of what is a normalization and denormalization. And with respect to normalization,
Okay.
so here Bill Inman is considered as the father of data warehouse, right? We have EF COD, E.F.CODD. He is considered as the father of the data warehouse. He is considered the father of the database. So he has proposed some rules of how to prepare a normalized database. So tomorrow class, I will just prepare a slide for you, Srini, so that it will be helpful for you for enhancing your knowledge. So that particular person has proposed some rules of how a normalized database should be. Okay, so basing on that particular rules, the different database vendors would be preparing their databases. His name is EF COD. So tomorrow's class, I will just cover those things. No problem. Yeah. So,
Okay.
yes.
Another question, Vinay. The three you said out of all those items for OLTP and overlap, there were 3 that are
Yes.
most obvious ones. The first one was OLTP stores, and overlap is for reading and also analysis.
Yes.
Then the second one you said is OLTP is for current data, but overlap has current plus historical.
Yes. Really.
What was the third one?
Third one was, this one, database data. The OLTP stores the data in a normalized fashion, and OLAP, the denormalized fashion.
Okay, that's it.
And fourth one, you can make a note like it contains the detailed information, OLTP and OLAP. All the time, it would be summary based information. And if you want detailed information also, you can dig into. But all the time, see, for example, if you do reporting in OLAP system, so what we would be focusing on? So what is my current year sales? Which means current year some 1 million. And if you want to dig into further, current month wise, so current year, but the same month wise, for example, 2013. So 2013, 1 million sales totally. And if you want to dig by month wise, then Jan to December, the total 1 million would be split according to the month wise. And if you want to day wise, you can go with day wise. But the initial view was the summary, but later on you are digging according to your requirement. If you want, you can dig. Otherwise, you can be happy with the first summary details only. So these are the few bullet points you can make a note, so that when somebody asks you, then you can tell him in one sentence. Boss, these are the primary differences which we would be focusing, where the difference between the OLTP and OLAP system is there. Okay, so. And in every data warehousing, there will be 3-level data warehousing concept. So same, whatever we have studied. So data staging, in the sense the different source systems, okay, different source systems would be coming, and we would be staging the data. Staging in the sense, we would be reading the data from the different sources and putting and making sure that they follow the same standards in order to store the data, as we have discussed earlier. Naming convention. So for example, date. So we need to make sure that from whatever the source system we are going to read the data, we are following the same naming convention. And with respect to data storage, this is called as the data warehousing environment. So with respect to information analysis, this is considered as the reporting area. So the different source systems, data warehousing ETL process, and the reporting. So this is how we need to look. So whenever we refer to the data warehousing environment, then we need to focus on these 3 areas: the different source systems, the ETL layer, and the reporting layer. So let's be specific to yeah, Srini.
Where does the modeling comes into picture? Is it before ETL or is it part of
No,
ETL?
it is one of the ETL process. So this modeling, so our SAP BW has 3 phases, right? Modeling, extraction, and reporting. So ETL is nothing but our modeling plus extraction.
Okay, so it covers both, and then just the reporting is different.
As per the reporting, that's a separate entity. So on the top of the SAP BW system, we would be creating the report using the reporting tool BEX Query Designer. We would be doing the reporting.
Okay, on the BEX, one is Query Designer, the other is what? The second one is what?
Analyzer. So this was analyzer. Yes.
Okay.
So this BEX is otherwise called as Business Explorer, but in shortcut, people would be using the word called BEX, Business Explorer. Analyzer is used to analyze the data, and Query Designer is to do the report, design the queries or design the reports according to the user requirements. Okay, so let's be specific to SAP BW. So this SAP BW system is especially suited for analyzing and presenting the data stored in a data warehouse. Okay, and good tools for creating individual applications. So these are the different tools for reporting purposes. And predefined information content, which is considered as the business content. So just make have an idea of these points. So we would be digging into details once we start our practicals, once we log into our SAP BW system and do the things. And theoretically, it does not depend on R3. R3 in the sense, so SAP ECC, SAP ERP, SAP R3, SAP R2, all these 4 words means the same. So if they want to market the product in the market, they would be using a SAP ERP system. But officially, that SAP ERP system is called as SAP ECC system. And if you dig into further, that SAP ECC system is otherwise called as R3 system or R2 system. So let me give you a clear explanation of what is this R3 and R3. So R3 stands for real-time 3-tier architecture. Real-time 3-tier architecture. So what this means is a system is defined in three layers. So first layer is called as the presentation layer, middle layer is called as the application layer, and the third layer is called as the database layer. Say for example, you have gone to Google and created a new Gmail account or a Yahoo account. So what you would be doing? First of all, you would be getting a form wherein you need to fill your details, your name, surname, a mobile number, state, and all the other stuff. So that layer is considered as a presentation layer where you are seeing the data. So once you enter your details and click on the save button, what is happening actually in the back end is, according to the logic, each and every field is validated, which means, for example, it is asking you to have a user ID first of all. So the user ID, it writes a back end condition. If this user ID exists, throw an error message to the presentation layer. So what is happening in the back end is, so every application, every software has three layers. So a presentation layer, application layer, and the database layer. So what is happening is, for example, Vinay, last name is Kumar, and some details it would be asking. It will be asking the username also. So I am giving the username called as Vinay3670. So first it would be validating that particular field data or value in the backend. It comes, okay, it is checking whether it is able to in the backend. So what is happening when you click on the save button? In the backend, a few processes would be there. So that process are called as a work process. So this application layer would be responsible for doing all these activities. So once you click on the save button, this application layer, one of the work process, would be taking that request and going into database and searching whether this value is already existing or not. If existing, what it would be telling is, it would be showing an error message. Username is already existing, please try another one. So we would be writing all these logics in the application layer. So application layer is like a CPU wherein it maintains all the things. So it interacts with database as well as the presentation layer. So whenever you query something, whenever you ask something, first of all, it would be going to the application layer. It understands the logic and such is the same in the database layer. If at all there is no existing record with the same username Vinay3670, then what it would telling is, okay, create a record with this username. And once it is created, then the work process would be intimating to the application layer. That is, a record was created. Then that would be shown in the presentation layer as, yes, username is created. Okay, from now onwards, you can log into the thing. So the next time when you open the gmail.com, it would be asking the username and the password. So once you give the username and the password, it validates in the backend. It validates in the backend, saying that, okay, in the backend, okay, this is the user name and the password. Had he given the correct details, then the application layer, one of the work process picks up the details, checks with the respect to backend database and confirms. Once it confirms, then it allows you to log into your account. Otherwise, it would be throwing an error message for you. Srini, I want to tell you one thing. I think there is some power problem over here. So is it possible for you to join 1 hour earlier? Hello?
Yes, that's what I was actually asking, but since you were in India now, I thought it would be too early for you.
No problem, Srini, because I don't want to disturb the candidates. So
Okay, so that will be fine. I mean, 7 o'clock Eastern would be fine for me.
it's fine for you, right? So if we talk about the IST, then 5:30 morning my time. So just join 1 hour earlier, because if this is the case, we can't continue the sessions, right? So I don't want to disturb the classes and make unhappy with the students, especially.
Okay. So tomorrow so 7 o'clock I'll join then.
7 o'clock, just 1 hour to you, whatever you joined today. So today you joined
Right.
at 8 p.m., right?
Yeah.
Yeah, okay. So tomorrow join at 5 p.m. So I think today I would be ending the class, Rini.
Okay.
Just
That's fine.
just go through. So now what is your today's work is, Just go to Google and type the different words like OLAP and OLTP systems. Difference between these systems, then you would be having good knowledge. Just analyze the things, just for a
Okay.
knowledge. Just analyze things and meet you tomorrow in the same time. That is our 5:30.
Oh,
Yes.
okay, Vinay, no problem.
Okay. Bye, Srini. Then have a nice day.
Bye. Bye.
Good night. Yeah.
Bye.